Very good afternoon. This is Naveena from the Department of Cybersecurity in the Institute of Aeronautical and Engineering. And today I came with the concept of the internet layers and under the network layer and the working of the IP addresses like IPv4 and IPv6. The network layer in the internet consisting of two types of addresses, IPv4 address and IPv6 address, as well as what is meant by IPv4 address with examples, and the network layer in the internet. After that, the architecture of the network layer in the internet. Next, the types of the IPv4. What are the parts of the IPv4? Those are related. The three parts: network part, host part, as well as the subnet number. The characteristics of the IPv4 and the advantages of the IPv4, the disadvantages of the IPv4, as well as the IPv4 datagram. That means datagram fragmentation, how the fragmentation will be done. And after that one, the second part of the IP addresses, IPv6, and how many parts the IPv6 can be divided, and how many types of IPv6 addresses will be there. There are three types, so we have to identify. And what are the advantages of the IPv6 and what are the disadvantages of the IPv6. First of all, and in my previous videos, since many videos and I have any to share, and I already discussed with many routing algorithms part 1, 2 and 3, congestion controlling algorithms, along with the network layer design issues and a part of that one. And in the last video and in my previous video, and I have discussed with routing algorithms. Out of that, the shortest path, distance vector routing algorithm, link state routing algorithm, flooding and hierarchical, routing with mobile host, routing with neighbors and discovering of the neighbors. We have already seen all the type of routing algorithms today. And what I mean to explain means, and I came with the concept of the network layer in the internet. The network layer in the internet. The first of all in this, what is the meant by IPv4 address? What is meant by IPv4 address? The internet protocols. The internet protocols. What we can call it as a IP. Can be divided into two types. The first one is IPv4 as well as IPv6. So first of all, we want to deal about the what is meant by IPv4 address with example. So coming to this one, the IP version 4. IP means internet protocol. V4 means version 4. V4 means version 4. These are the type of addresses which are present in the internet layer. I mean, which are present in the network layer of the internet part, which related to the internet part of a network layer consisting of 32-bit integers that can be expressed in hexadecimal notation. The more common format known as dotted quad or dotted decimal, which will be represented by means of x dot, and x comma, where each x can be any value between 0 and 255. That means the decimal value range is between 0 and 255. For example, if you can take the example of a 192.0.2.146 is a valid IP address in the internet. That means how it will be divided means 172. If you can take the example of this one, 172 is nothing but the IPv4 address in dotted decimal notation, and 172 we can be decided or in the decimal notation or referred in the decimal notation by means of this type of binary format. 16s will be in the binary format. 254 will be under the code of this binary format. 1 will be this type of binary format. So for every number, 8 bits of code we need to identify. Hence, we need to give the 32-bit integers, 32-bit decimal integers for the IPv4 address. IPv4 address consisting of 32 bits, 32-bit addressing, 4 bits are present. 32 bits under the 4 bits are present. So hence the IPv4 consisting of 32-bit integers. So each bit consisting of 8 bits. 8 into 4 is equal to 32 bits. 32 bits. Hence, an IPv4 address consisting of 32-bit integers that can be expressed in hexadecimal notation. So, coming to this, the network layer in the internet can be viewed as a collection of subnet of works. Collection of subnet of works are autonomous systems or independent systems. Second point, if you want to define the network layer in the internet protocols, these are playing a vital roles in the network layer. We should be divided into two types, IPv4 and IPv6. The internet protocol hosts the whole internet together is a communication in the internet works, which are as follows. The first one is the transport layer takes data streams and breaks them into datagrams. The transport layer takes the data into data streams, breaks them into datagrams. Each datagram is transmitted through the internet. When all the pieces finally get to the destination part or a destination mission, they are reassembled by means of a network layer which inserts it into the receiving process input stream. So again, and how we'll see, let us see how the architecture of internet network layer follows. Means this is one of the architectural model of the internet of network layer. The first one is the internet network layer, what we can call it as a IP. The internet network layer components. The first one is the IP protocol consisting of addressing, datagram, format and handling, and routing protocols and ICMP protocols. Again, it will be divided into transport layer, which is holding the two types of protocols, TCP, transmission control protocol, as well as the UDP, user datagram protocol. And again of this is the network layer, and after that one, the link layer, and after that one, physical layer. And here, if you can identify the functions under the transport layer, a part of that network layer, the network layer functions here, the red type of symbol we have to identify. That means the network layer means routing of the protocols. The first one is routing of the protocols. What type of protocols? That means based on that path selection, those protocols are RIP, OSPF and BGP. And next one is maintaining the internet protocols. The first one is network layer function is this one. Second one is maintaining the IP protocols. First one is IPv4 and IPv6, which are meant for addressing conventions as well as datagrams format. That means after that one, packet handling conventions. After that one, forwarding table, what we can call it as a routing table, and it consisting of again ICMP protocol, which is meant for error reporting as well as router signaling. And coming to this IPv4 addresses, and what I have explained, coming to the according to a discussion topic, that means internet protocol addresses can be divided into two types. Those are IPv4 address as well as the IPv6 addresses. So IP stands for internet protocol and V4 stands for version 4, IPv4 IPv4. Hence we can see the parts of IPv4. The first part is network part, second one is a host part, third part is subnet number. So coming to this, the parts of IPv4, the network part. The network part indicates the distinctively variety that's appointed under the network layer. So the network part conjointly identifies the category of the network that's assigned. Category of the network that's assigned. Coming to that host part, the host part uniquely identifies the mission on your networks. This part of the IPv4 address is assigned to every host. For each host on the network part is the same. However, the host half must vary. The host half must vary. Coming to the subnet number, this is the nano obligatory part of IPv4. IPv4 and local networks or LANs that have massive number of hosts are divided into subnets, and subnet numbers are appointed according to that only. According to that subnet only, the numbers will be appointed or allotted. So these are the three main parts which are included or divided under the IPv4 standards. So coming to this, the characteristics of IPv4. IPv4 could be able to 32-bit IP address. It will be recognized as a 32-bit IP address, and IPv4 could be a numeric address which will be denoted by means of a hexadecimal format, and its bits are separated by means of a dot. Bits are separated by means of a dot. The number of the header files is 12 and the length of the header file is 20. The number is 12. The length is 20. Number is equal to 12 and the length is equal to 20. It has unicast, broadcast and multicast style of addresses consisting of three types of addresses. The first one is unicast address, second one is the broadcast, and third one is the multicast style of addresses. IPv4 supports VLSM, what we can call it as a virtual length subnet mask. Virtual length subnet mask, as well as IPv4 uses the post address resolution protocol, what we can call it as a PARP, post address resolution protocol, to map to the MAC address. And RIP, again, the last point, RIP may be routing protocol supported by the routed daemon. Networks ought to be designed either manually or with DHCP. Packet fragmentation permits from routers and casting about the host. And coming to this, the advantages of IPv4. And IPv4 is under the security basis, it permits encryption to keep up privacy and security formats in a very secure manner. And IPv4 network allocation is significant and presently has quite 85,000 practical routers will be there. And third point is, it becomes easy to attach multiple devices across an outsized networks, what we can call it as a NAT. Whether while NAT is present or not, it becomes very easy to attach multiple devices across an outsized network. So this is a model of communication, so provides quality of service, also as economical knowledge transfer. IPv4 addresses are redefined and permit flawless encoding. That means routing is a lot of scalable and economical as a result of the addressing is collectively more effectively. Collective as well as more effective. Why? Because the routing can be designed, it is a lot of scalable and economical. As a result of this, the addressing of a routing under the IPv4 is collective than more effective. And data communications across the network becomes a lot of specific in multicast organization. So these are the main advantages. The first one is the IPv4 network allocation. Next one, becomes easy to attach multiple devices. Next one, this is the model of communication. Next, IPv4 addresses are redefined, and They are permit lawful encoding, and routing is scalable as well as economical, and data communications across the networks, it becomes a lot specific multicast organizations. And some of the advantages which might be remind limits net growth for existing users and hinders the use of the net for brand new users. And internet routing, it will be done in efficient under the format of IPv4 standards. IPv4 standards. Next, IPv4 consisting of high system management prices and it's labor intensive, complex as well as slow, frequent to errors. After that one, the next point is security features are non-obligatory. And after that one, difficult to future support for future desires as it is a result oriented of adding it on. It is extremely high overhead since it hinders the flexibility to attach everything over IP. Next, so coming to this IPv4 datagram. What do you mean by a datagram and why IPv4 datagram fragmentation is required? What do you mean by a datagram? When a stream of data or a bulk of data is about to travel from one source to the destination. For the sake of easy traveling from one source to the another destination, this data packet or data stream will be divided into small packets. These small packets, what we can call it as a datagrams. So, the splitting of the data stream for the easy convenience of mode of sending or forwarding from one source to the another destination or from one node to the another destination, the data stream can able to split it into the data packets in the form of a datagrams. That data packets, what we can call it as a datagram. Why the IPv4 datagram fragmentation will be required means different networks may have different maximum transmission unit. For example, due to the difference which will be occurred in the LAN technologies nowadays, when one network wants to transmit datagrams to another type of networks within the smaller MTU, what we can call it as a maximum transmission unit, the routers on the same path may fragment and reimburse the datagrams whenever it reaches the destination. That is the use of main, the data will be fragmented at the end of a destination only. Okay. So how the fragmentation will be done? So why the fragmentation is required under the IPv4 datagram and how the fragmentation it will be happened or occurred. When a packet is received at the router, the destination address is examined and MTU is determined. When a packet is received at the router, the source, whenever a packet is about to move from one source to the another destination, it will be received by means of a router and able to transmit started by means of a one source router. So whenever the destination address is examined and MTU is determined, if size of the packet is bigger than the MTU, and it will be saying do not fragment, DF will be obtained. Bit in the set of 0 in the header. Then the packet is fragmented into parts and sent one by one. The maximum size of each fragment in the MTU minus is the IP address size minimum 20 bytes and maximum 60 bytes. 20 bytes to 60 bytes of data only can able to travel under the MTU transmission from one node to the another node. Under this fragmentation is done. Whenever the fragmentation is done, it's a mean of 20 bytes to 60 byte of bits can able to travel from one node to the another node. Then the packet is fragmented into the parts and sent it one by one. So this is the how the fragmentation will be done and what is the requirement of the fragmentation under the IPv4 standards. So coming to this, again I have already discussed based on that, the internet protocols can be divided into the two types of protocols. The first one is the IPv4, second one is the IPv6. IPv4 already discussed, and coming to that, the IPv6, the IP address is your digital identity. It's a network address for your computer. So the internet knows where to send you emails, data, and a message, etc. So IP address is nothing but your digital identity. It's a network address. It's a network address for your computer. So the internet knows where to send your emails, data, and the information, etc. Coming to the IPv4 Internet Protocol version 6 is a network layer protocol that allows communication to take place over the network. So coming to this, one of the points we need to discuss, some of the points under the IPv6 addresses. The IPv6 address consisting of 8 groups of 4 hexadecimal digits. Consisting of 8 groups of 4 hexadecimal digits. 4 hexadecimal digits. Here is an example of IPv6 address 3001.0DA8.75A3. 4 bytes of zeros, 8 to 2E 03707334. This is one of the example for the mode of a IPv6. This new address version is being deployed to fill the need for more internet addresses, and it is aimed to resolve issues which are associated with IPv4. With 128-bit address space, it allows 340 undecillion unique address space. IPv6, also called IPNG. IPNG means Internet Protocol Next Generation. It allows 340 undecillion unique address spaces with 128-bit address space for the IPNG generations, which is meant to resolve the issues associated with IPv4. IPv6 is meant to resolve issues which are associated with IPv4. And coming to this one, and what are the supportive nature of IPv6 addresses? If you can determine or define, IPv6 supports a theoretical maximum of 340 and 282 and 366, 920, 938, 463, as well as 374 and 607, as well as 431 and 4768 and 211 and 456. So to keep it straightforward, we will never run out of IP addresses again and again. So here we have to identify the IPv6 also divided into the 3 types of addresses like the IPv4 standard. So what are the 3 types of addresses? Let us see one by one. Now that we know about what is IPv6 address, let's take a look at its different types of IPv6 addresses which should be included under the IPv6 format. The first one is unicast address. It identifies a unique node on a network and usually refers to a single sender or a single receiver. That means unicast means one single sender will be there, one single receiver will be there. By this, the type of data packets, they will travel or forwarding or sending from one sender to the another receiver. This is the unicast address. That means the data packet consisting of the destination address of only one destination address. The data packet, it is about to travel or it is about to forward or it is about to sending consisting of only one type of address. Hence, the multicast addresses it represents a group of IP devices and can only be used as the destination of a datagram. as the destination of a datagram means these data packets consisting of two types of addresses, whether it will be address 1, address 2 or destination 1, destination 2. Like that only a data packet can able to travel from one node to the another node by means of a multiple number of address. That means a data packet needs to select on which type of path it can able to travel or forwarded from one node to the another node or from one sender to the another receiver. So, any caste of address, this is the third part of addressing which should be included under IPv4. It is assigned to a set of interfaces which typically belongs to different nodes. That set of internodes means, suppose if one consisting of node 1 and it will be having the node 2 which will be connected with different number of nodes like N3, N4 and N5. So it is assigned to a set of interfaces which typically belongs to different types of nodes. So after that one, coming to this, the advantages of IPv6. What are the main advantages while you are dealing or defining with the IPv6 is reliability. After that one, the fast speeds, stringent security. So, most important one is the global networking. Coming to this, the first advantage is what we can call it as a reliability. Fast speeds, IPv6 supports multicast rather than the broadcast in IPv4. This feature allows the bandwidth intensive packet flows like multimedia streams to be sent to multiple destinations all at once. Coming to this stringent security, it is otherwise called as IP security, which provides confidentiality and data integrity in the embedded system of IPv6, provides the confidentiality and data integrity with embedded into IPv6. Coming to this, the routing efficiency. Most importantly, it's the final solution for growing the nodes in a global network, which is meant for growing the nodes in a global network. These are some of the advantages of IPv6. So coming to this, the disadvantages of IPv6. These are mainly the two types of disadvantages of IPv6 we need to identify. The first one is conversion. Due to widespread present usage of IPv4, it will take a long period to completely shift to IPv6. So coming to this, the communication part, the IPv4 and IPv6 missions cannot communicate directly with each other. They need an intermediate technology to communicate with one another. That it should be possible in that limit only. So these are the main disadvantages of IPv6. The first one is the conversion, second one is the communication. And again, I need to make the review of all the internet IP protocols one by one. What do you mean by IPv4? And I have already discussed the network layer in the internet. And coming to this one, and what is a type of subnet or autonomous systems, and the architecture of an internet layer under the network layer, like the IP protocols, what we can call it as routing protocols and ICMP protocols. After that, the parts of IPv4, network part and the host part as well as the subnet number. These are the three types of parts which are involved under the IPv4. Coming to this, the characteristics of IPv4. So, at the end of this video, I hope the students can able to learn, or the outcome of this video is nothing but what is the IPv4 address as well as the network layer in the internet, After that one, the IP protocols which are meant for addressing datagram format and the routing protocols of ICMP protocol. Again, the parts of the IPv4 like network part and host part as well as the subnet number according to the IPv4 version. And what are the characteristics of IPv4? Like it is a 32-bit address and consisting of three types of addresses: unicast, broadcast as well as multicast. And IPv4 could be a numeric address and it supports VLSM, virtual length subnet mask. IPv4 uses the post address resolution protocol, what we can call it as a ARP, and RIP may be a routing protocol supported by the routed domain. And after that one, the advantages of the IPv4, like what are the advantages which should be present in the internet layer of a IPv4 consisting of the routing. It gives the data communication and it is a model of communication. It becomes easy to attach multiple devices across an outsized network, and IPv4 network allocation is significant and presently has quite consisting of 85,000 practical routers. Again, on some of the advantages are nothing but, and internet routing is more efficiently working with IPv4. Next, and it is consisting of high system management prices like labor intensive, complex, slow and frequent to errors. Security features are non-obligatory. So after that one, and the datagram fragmentation and how it will be required means it will be required for the maximum transmission unit, what we can call it as a MTU. By this only we can able to move or split the data of 20 bytes to 60 bytes of data from one node to the another node. When a datagram is about to travel or send it by means of a one sender to the another receiver, the maximum size of each fragment is the MTU minus the IP header size. Why? Because it is when one network wants to transmit datagrams to a network with a smaller means of unit, what we can call it as a MTU only. The routers on path may be fragmented and reassemble the datagrams at the destination end itself. And after that one, mainly the IP addresses and IPv6 or Internet Protocol version of 6 is a network layer protocol which allows communication to take place over the network. So again, coming to this IPv4 address consisting of 8 groups as well as the 4 hexadecimal digits according to the given example, and the new IP address version, and what it is aim is to resolve the issues which are associated with IPv4. IPv6 is meant for what are the unresolved issues or resolved issues which are associated with IPv4, and it consisting of with 128 bit space. It allows 340 undecillion unique address space. IPv4 also called IPNG, what we can call it as Internet Protocol Next Generation, as well as and how the mode of bytes or the characters like IPv6 supports, and what are the types of IPv6 addresses. Unicast address refers to a single sender consisting of single receiver. Multicast address, group of IP devices and can be used as a destination like with multiple addresses. Anycast address means a set of interfaces that typically belongs to different types of nodes. Coming to this, the advantages of the IPv6 consisting of reliability, faster speeds, stringent security as well as the routing efficiency. And while coming to the disadvantages of the IPv6, it is nothing but the conversion and the communication. That means IPv4 and IPv6 machines cannot communicate directly with each other. That is the main drawback or the disadvantages of the IPv6. I want to end this video and I hope this video will be useful, and I try to reach the students in a good about manner, and hope this video should be useful to the students and please keep watching for my upcoming video. Thank you, one and all.
Like, share and subscribe. Hit the bell icon for more updates.